All right, what we're going to pick up on is we're going to look at some conditional operators. And what happens is we can, let me go back a screen here. We can replace a complicated if statement, the if x is greater than 0, then y equals 1, else y equals negative 1. We can turn this into a single set of statements with the question mark. So what happens is the comparison if precedes the question mark. Then what happens for the truth follows the question mark. And then what happens for the else statement follows a colon. And so this assigns 1 into y if x is greater than 0. Otherwise, it assigns negative 1 to y. And so we get these operators that we can use to simplify if conditionals. For example, if we check if a number is even, an even number when remainder divided by 2 gives 0. And this can be put, this entire print statement can be put into one print statement. So this, if the number is divisible by 2, print it's even, else print the number is odd, can be turned into print number percent 2, or remainder division, if it's equal to 0. The question mark makes this into an if statement, and then it will print number plus is even, else number plus is odd. So the results of this conditional operator in parentheses gets fed to the system out.println. And so this is a quick way to do if statements if they can be done as a one-liner and there is a value that is taken on. And so conditional operator is the expression, the question mark, and then in two other expressions. The expression 1 gets passed out of the conditional operator if the Boolean expression is true, and expression 2 gets passed out of the Boolean out of the operator if the Boolean expression is false. What this leads to is an idea of operator precedence. If we have multiple operators in a statement, then the things that are run first go from top to bottom. So increment and decrement operators go first. The plus and minus and the pre-decrement and pre-increment and pre-decrement operators. Then in any type of casting, followed by any type of negation. Our arithmetic operators fall here, and then the relation operators. Now notice the less than or equal to have higher precedence than the equality operators. Then in any conditional statements, exclusive or and conditional or. And then in assignments. And so parentheses can override these with parentheses taking precedence over the precedence table that we looked at. Just like mathematics, if you bind something in parentheses, what's inside the parentheses will happen first. So if we say a minus b plus c minus d, because this reads left to right, a minus b is done first, then we add c, then we subtract d. You can do this with multiple parentheses. But notice assignment operators read right to left. So a equals b plus equals c equals 5. We need to spill from the right into a. So 5 gets assigned to c, hence the parentheses over here first. Then the value of c gets assigned to b, the outer parentheses. And then the result of those assignments spills into a. Generally, it's good form to break these up into separate lines, but you can compound statements. So for example, we have this comparison here where 3 plus 4 times 4 is greater than 5 times parentheses 4 plus 3 minus 1. And so if we evaluate it, the parentheses will happen first. And so this turns into a 7. Then in multiplication happens. And so the left-hand side becomes 3 plus 16. And the right-hand side becomes 5 times 7, or 35. Then the additions happen. So 3 plus 16 is 19. And the 35 minus 1 is 34. Then in the conditional operator comes into play. And in the operator preference in the appendix to the book, they have some extra ideas on this. But this really kind of wraps up chapter 4. Operator precedence and lines where you have multiple comparisons going through, it is sometimes better to break your code up into sections. And in chapter 4, we're going to be looking at writing methods. But what I want to do with is I want to continue this first mini lecture by looking at mathematical expressions. So let me switch over here. And yep, good. And we'll start chapter 4. And so in chapter 4, we're going to be looking at the math class, the character type, and the different encoding styles for characters, and special character sequences, which we've already introduced as we've been doing print statements. We're going to look at taking a numeric value and turning it into a character, and taking a character and turning it into an integer. We'll look at ways of comparing characters. And then we're going to look at objects and instant methods. And then we're going to take some time and look at the string object. And the string object is a very special object that we'll be using. Very similar to how we've been using scanner objects, string objects work with text of multiple characters. We'll read strings in from the console, and we'll compare strings with the built-in methods. We'll find strings inside of other strings, which are called substrings, and we'll look for the position of particular characters. But our talk for this first lecture are the math classes. And so the first thing that we're going to see is within math, there are constants. So, and what I'm going to do is I'm going to use the sandbox. If another ellipse doesn't open here, here we go. Let's see if I can get over into my sandbox here. Let's come over to ellipse. There we go. Ellipse is showing. So what I'm going to do is I'm going to go to File, and I'm going to create a new Java package. Now I know the sub window that comes up here is not viewable, but I'm going to call the project lowercase chapter 4. And I'm going to use the project folder as root for source and class files. Those are the only things I need to add. And now I have a chapter 4 in here. And I'm going to create a new class. And again, I'm going to call it sandbox. And I'm going to choose public static void. So we have a place to work on code here. What I want to do is I want to look at our calculating an area. So I'm going to go back to the circle function that we started with. So I'm going to include a scanner. What happened to getting a package error for a change? Got a package error on the creation. I'm going to recreate my project here. All right, I had to recreate the project. For some reason, it didn't see the package on the initial project. I've seen this happen a couple times in Java. So I deleted the project chapter 4 and I recreated it. And now it sees the package properly. So I'll come back in and we'll import java.c .util.scanner. And we're going to create a double for radius and a double for area. Now I'm not going, we'll enter a radius. Notice I'm not putting much comments here because this is my sandbox. So we'll make a scanner object. We'll create the new object and we'll link it to the keyboard input stream. If I can spell today, there we go. And we'll make the radius equal input next double that we get from there. And then in our area calculation will be, well, now we're going to use the math.pow radius, and we're going to square it times pi. And so notice how we've improved our readability of our code. This is going to be taking the radius to the second power, or squaring it, and we have a constant for pi so that we don't have to input a area of a circle, that we don't have to input a value for pi in our code of radius, and we'll put a percent, we'll put 2 decimal places, is percent %f, and we'll do 2 decimal places, and we'll feed it the variables radius and area. And again, because I'm scrolling off the screen here, I'll come down here and we'll see if I put the right radius of 5, and let's see, I get 5.0 with a 0.2 in it. So let's try there. Put my 5.2. There we go. I have to put my 0.2s in front. So our math functions, this is why I like the sandbox. We can program and make mistakes and correct them. So we've now using built-in math functions instead of doing radius times radius, and instead of having to encode a value for pi. And again, we're going back to the printf statement, where this is telling me I'm going to have 5 digits, 2 of them after the decimal place. And I'm feeding it the variables radius and area. So these math functions have the ability to look at special values, Euler's constant, which is the exponential, a natural base, 2.718, and continuing, is also a constant. We also have methods for doing particular trigonometric functions, exponential functions, rounding, and random numbers. So for our trig functions, they take a double that is in radian measure. So math.sin 0 returns 0, math.sin pi over 6, well, this is the sine value of the radians pi over 6, which is 1/2. And so we have the sine function, the cosine function, the tangent function, the arc sine, the arc arc cosine, the arc sine, and the arc tangent. And these are the 3 buttons on most calculators, and these are the reverse functions. So if I put the output of sine being 1/2, it would return for me the radian value of pi over 6, which would be a decimal based. And then we also have the ability to convert from radians to radians. So if I use 2 radians, I get 90 degrees. It would put in pi over 2. So we can enter things in degrees and get them returned in radians. So we have the ability to work with trig functions. And we'll look at some of these as we look at some of our programs. We also have exponential methods. So exp is e raised to the power of whatever the double is in there. And this would be similar to your calculators have a log and an ln button. And then if you shift and you hit the second key for them, you'll get e to the power or 10 to the power. Now, in a lot of old mathematical textbooks and on computer programs, log is what's on the calculator as the ln function, or the inverse of the exponential. And log 10 on a calculator is the log function, or the inverse of 10 to a power. Power itself is a function we've been using, math.pow. You give the number and you give it to the power of b. And then square root, math.square root gives the square root of a function. Rounding itself has some interesting features in computers. We can take a ceiling which rounds up to the nearest higher integer, but it's going to return it as a doubled value. So for example, let's look at some ceiling inputs and outputs. So I'm going to go back to my sandbox here. We're going to input a double and we're going to use the ceiling feature on it. So let me input number 1 and we'll output the number 2 for right now. And so I'll come down here, this will be number 1. This will be number 2. And we're going to use the ceiling. So math dot ceil, and we'll give it number 1. And the ceiling of, let's give ourselves some more decimal places. The ceiling of a number is again, we're going to use our printf. I am hitting all the autocompletes. And so I'm going to give it number 1 and number 2. So this is going to take the ceiling function. Sorry, I like closing out my scanner on the number that I enter. So again, using my sandbox to do some things. Oops, I shouldn't say enter a radius, should I? Well, let's 3.21, and it raises it to 4. Change that to number. So the ceiling function pushes up to the next highest integer. Doesn't matter if it's 3.5, there's no rounding done. It looks at this number and moves to the next integer, but it returns it as a double. A thing to notice with that is negative 2.1387 gets pushed up to negative 2 because negative 2 is larger than negative 2.137. So the ceiling always moves up in value. It doesn't matter, it's not moving up or down in absolute value. So if your integer is negative, it's going to move up to the next highest. We also have a companion function called floor, which does the opposite. It pulls down. So again, we'll enter a number. And if I enter 3.712, it pushes the number down to 3. It removes all the decimal bits and leaves the integer part. If we also look at a negative number, it pulls it down, which is to a -3. So ceiling and floor move in opposite directions in what we have available. We also have round integer, which is rounded to the nearest integer. If they're equally close to the integers, an even one is returned the even one is returned. So if you have, and we'll look at our int to see what it means by being equally close to two integers. We also have an integer round float that will return an integer, and it uses a floor function on the number plus 0.5. So you give it a float, it adds a half to it, and it returns the integer. It floors it and returns the integer. What the 0.5 will do is it will move it up or down. And this can happen within a long or a integer. So let's look at the rint, and we'll compare it to the round function. So let's use rint. And so rounding percent 5.2 gives percent 5.2. So I'm going to use the rint function. We're going to round a double to its nearest integer. So let's start with 2.314. Oops. 5. Did I not convert? Oh, I forgot to put my F's in here. There we go. 2.3145 rounds to 2 because this rounds down. Let's do 2.781. It rounds up. So this is the rounding we're used to. But look at what happens if I do 2.5. It moves to the even number. And this is a statistical rounding technique. In statistics, if you round at 2.5, always pushing up, you can skew your numbers upwards. So switching between even and odd. So 2.5 was even. Let's look at rounding 3.5. It pushes up to 4. So if it's exactly halfway, if it's at a 0.5, then it will go to the nearest even number on that. And so that's the rint feature. Now let's come back here and just read what we're going to round. We're going to give a float, and it's going to return an integer. So I'm going to need to change my output to an integer, and then we're going to do a standard round. So let's change number 2 to an int. And what did I flip back over? I need to flip back over to Eclipse, sorry. So I changed my number 2 to an int, and now I'm going to use the round function, which will take a float or a double. I want to use a long, that's right. Just really quick, right? Since I'm giving it a double, I need to get a long back out of it. And so we'll make this long. And this needs to become D. So I think I'm getting a number 1. I'm using the round feature. I'm giving it a double, so I need to put it into a long, and it's going to take my number and use standardized rounding on it to the nearest integer. And so this turns a decimal to an integer. And so 3.56718 goes up to 4. And 2.135671, or 2, goes down to 2. But notice it's outputting an integer type. And so this would be a great rounding feature instead of casting it as an integer where it drops off the decimal places. We also have the ability to pull out the max and min of two numbers. If we give it two numbers, it'll tell us which one is larger or smaller, which works great with variables. So we have the max and min function. We have the absolute value, which returns the value without the sign. And then we have a random number. And random we're going to take some time looking at here. Random returns a double value that can be 0 all the way up to 1, but not including 1. So it gives decimal places. I really want to play with random a bit here. And we're going to look at what we can do with random. But I'm going to go through a couple of the slides, and then we'll play with it a bit. So you generate a random number that greater than or equal to 0 and less than 1. And then I can multiply that number by 10 and cast it as an integer to give me integers between 0 and 9. I can add to whatever comes out of that to give a range of numbers. So we have this ability, this thing that generates a decimal, to have it generate different decimal or different integer types. And so we can give it a range. We can generate a random number between A and A plus B, but it won't include A plus B. And we do that by adding A to the output of math.random times B. And so this is what I want to play with here. Again, we'll keep our sandbox here. We won't need any scanner object right now, so I'll just come back up here. I'm going to delete everything. And what we're going to do is we're going to make an integer that is random number. And we're going to do that by we're going to cast the output. Let's start. Let's just look at system.out.println math.random, which will output a double. So let's just look at the raw nature of this. So I've trimmed my sandbox down. All I'm doing is I'm calling the math.random function and having it print to the screen. So if I run it, I get a decimal number. And it's random. And it's trapped between 0 and 1. It can be 0, but it can never be 1. And so I get all these different random numbers. Well, let's multiply it by 10. So now my lowest number can be 0, but my highest number can be 0.9 point something. And so notice I've moved the decimal place over 1 by multiplying it by 10. Can still get a 0 point something as I run these different random numbers, trying to see what pops out of it. 2.422, 4.22, 9.01, 4.1, as we still get a 0. Now, what I can do is I can cast what comes out of this as an integer, which means it drops the decimal places. Wait a minute, I'm getting all zeros. Well, what happens is the integer will affect math.random before it multiplies it by 10. And because it's a number between 0 and 1, if I take it to an integer, the integer will always be 0. So what I need to do is I need to use my parentheses to get that multiplying by 10 to pop out of it first. Now if I cast it as an integer, now I'll get numbers between 0 and 9. There's a 0, there's a 9, 0, 9, 2. And so I get numbers between 0 and 9. Now if I wanted the numbers between 1 and 10, then I need to add a 1 to it. And now this will give me 1 to 1 to 11, not including 11. Well, that should give me a 1 to 10. So let's try it. 7, 9, 3, 4. Yeah, testing random numbers can take a bit. As you try different values, there's the ones, there's the lower end. Do I get any 10s out of this? Hey, there's a 10. And I don't see anything bigger than a 10 or less than a 1. And so here we now have the ability to have the computer generate numbers for us with a good random feature that's a little bit stronger than the random we were using by using the system clock. All right, what I'm going to do here is I'm going to do some sample programs using different mathematical features in some separate videos, and then we're going to look at character data in the next kind of mini lecture.